All right, so what we're going to do today, I'm going to introduce the beginning of section 4, and then we're going to kind of like take a break and have a quiz. And then after our quiz, we will continue with section 4. Okay? What I want to get out of today is the concept of one-sided limits. So we've already talked about the concept of if we're coming from the left side and the right side, and we're coming from the left side, if they don't match up, then the limit doesn't exist. But we've never actually talked about those sides individually, which is what we're going to do today. Okay? So we're going to talk about the concept of a one-sided limit. You'll have a homework assignment, and then tomorrow we'll do some review for the quiz. Tomorrow is the pep rally, and the pep rally is in between 3rd and 4th, correct? How many of you will be late to this class due to the pep rally? Okay, not as many as I thought. Good. So tomorrow we'll go over homework. We'll start a review activity. If you're not here when we start the review activity, then I'll just throw you in as we go. Okay? All right, so one-sided limits. Just before I actually give you the official definition, go ahead and just turn to your partner and tell them what you think a one-sided limit will be. All right. Does anybody want to tell me what they shared with their partner? Aaron, you look excited.
When you're going from the right side, you're going to have a different limit than when you're coming from the left side.
Okay. So what we're actually going to do is we're going to look at just a right-hand limit and give it a value, and just a left-hand limit and give it a value. Okay, good. And then if they're not the same, then we know it doesn't exist. I like it.
We were thinking there's going to maybe be a restriction. So you had a limit, and then it was like comma x is greater than or equal to 2 or whatever it is. So that way it excludes stuff, or like there's kind of like asymptote there.
I see what you're saying. So what this will give us the ability is to look at only one side of the limit. So we're always going to stick to a specific x value. Like we're not going to look at like multiple x values in one limit. But essentially, you've been doing one-sided limits, and you didn't know it. Okay? So biggest thing about today is the notation. Do you see how there's this little negative superscript right here? That means we're approaching 2 from the left side. Okay? So if you have a little negative superscript, that's asking you to approach that x value only from the left side. Please do not feel like you have to write every single word down that I have up here. Okay? This says, what is the behavior of the function as x approaches 2 from the left side? I bet you could paraphrase that in your notes. To left side. Or what's the y value from the left? Or something like that. So use some intuition here. A right-sided limit, what's going to be in the superscript? When you have a little plus sign as a superscript, and it's so tiny, it's hard to see, so I'll make it stand out a little bit more. But when you have a positive sign in the superscript, that's asking for the limits only from the right side. So what is the y value we're approaching when we come from the left side of that x value? Sorry, I was like saying like kind of in general, and then you gave me a specific answer. Thank you, Nick. I'm on the same page as you. Okay. So both of these would be 7, right? Okay. Both of these would be 7, which. Okay, so we get it. Okay. Okay. So first, let's just look at graphs. Okay. Take some time to draw this graph. Sorry, Nick, you were like ahead of my thought process. As you're drawing, I have not graded your quiz corrections yet. To be very honest, I probably won't until this weekend. Okay. The first week of school is just crazy for everybody, right? So when you're talking to your parents about your grades, just tell them that sometime this weekend they'll be updated, okay?
That's what you need until your grades. Hi, Keith.
I might start them tonight, but I just. Okay.
You already talked to my parents at church, so.
What?
You already talked to my parents at church, like church really updated.
Oh yeah, you talked to my dad too. I totally forgot my grandma's from Garden City.
Yeah.
Because that big boy was there.
Yeah.
She couldn't go
That's
in.
what people usually don't know what Garden City is.
Yeah.
So, like, when people do, all right, so let me get my notes. I want to look at the limit as x approaches 1. That plus sign means from the right side. Sorry, I want it to be -1 for this to work. Okay. As x approaches -1 from the right side. Here's -1 from the right side. Is here? What y value are we approaching? The limit as x approaches -1 from the left side. Here's -1 from the left side. We're approaching that hole, which is at 2. We can have that. Okay, that's fine. A right-sided limit. Just look at the value of the y. Left-sided limit. Look at the value of the y. However, if I ask you for the limit as x approaches -1, what would you tell me? I heard mumbles. Our limit would not exist because the right side and the left side do not match. Therefore, our limit does not exist. Okay. So now we can actually like put some notation there instead of just like talking about it. Okay, see how that works? Okay, so at your pod, please find me these limits. Okay? you got about a minute or so to both write these down and evaluate them with your pod.
First one, too. It's not like.
And then just put
What does that mean?
Okay. The first one, I got 2.
I got 2.
Yeah, and it says like from the left or the right, that's just like the function of the point.
On which side? Honestly, it's not pretty hard.
I don't want to find it anywhere.
Oh, it's positive.
I'm going to kindly remind you of my cell phone rule that I want them where? In your bag? All right, let's talk about these all together. Colby,
Yes.
first of all, what does this say?
As X approaches 2 from the left.
Limit as x approaches 2 from the left. And what would that be?
2.
2. Would it matter if I had asked you from the right? Left and right matched up. Okay, the left and right would have been the same for that particular one. Okay, thank you. Lauren, what about this one? What does this read?
X approaches 1 from the left.
Okay, and that would be?
It is 3.
Do we agree on that one? Who said no? Maybe someone said yes and it sounded like no. Okay. All right. Krista, can you read this one for me?
1.
Okay, the answer is 1. Could you read what like this says right here?
Limit of x as it approaches -3 from the right.
Okay, -3 from the right. Thank you. And your answer you got is 1. Do you agree with 1?
Yes.
Yes.
Okay, thank you. I know that I'm being like really kind of weird about the notation, but I want you to be able to understand what the notation means, so I'm making you read it out loud. Okay? All right, now write down this function. What kind of function is this? Piecewise function. Well, we all know how Turner feels about piecewise functions. Any function? What are you doing? I hear everything that's said. Okay. I'm asking us to find the limit as x approaches 0. Does anybody have an issue with that? Like you're not worried about it at all?
Oh, I thought you were.
Oh, like does anybody have an issue with the limit being at 0? Maybe that's how I should word it.
Yes,
Why is it a problem?
because the second function, it says x has to be greater.
Okay, our domain breaks at 0. So we have one piece to the left of 0 and one piece to the right of 0. See what I'm getting at here? Okay, if I ask you, oh, we're good. I didn't trip and it didn't unplug. If I ask you for the limit of a piecewise function, if that limit is at the break in the domain, then we have to consider a right and left hand limit separately because we have two different pieces on each side of that value. Okay? So let's consider the limit as x approaches 0 from the left. And you better believe I'm going to make you show this work. If you have an answer with no work, you're not getting full credit. I need to see with my eyes that you thought about the left and right hand limits separately. Okay? So if I'm talking about the limit as x approaches 0 from the left, which piece would I be concerned with? The top one, because x is less than or equal to 0. That's to the left of 0. So we would plug 0 in to that first function for our limit.
By showing work then, do you want us to write out 0 plus 1? Or do you just want us to write the substitute superscript?
Great question. I need to see at the very least what I just underlined in red. Oh! I'm all flustered now. Better? Okay. Things happen like that sometimes. We're all human.
Just remember that.
Okay. Are we all on the same page now? I need to at least see like the limit notation with the right and the left. Okay? Alright, so then the limit as x approaches 0 from the right side, okay, this x squared plus 1, our domain is to the right of 0. So we would be plugging in to the x squared plus 1. Got that one figured out. What's true about the right and the left? They agree, which means we can say that that limit is 1. There's the graph of it so you can see what's happening. Okay? So when those two, it's kind of like the open circle and the closed circle, they overlap from the two pieces. When that happens, that limit is going to exist. Oh, that's why you were. Yes.
What would we do if the two limits weren't, like, they didn't agree?
Great question. If our right and left hand limit does not agree, what do we like to say? Doesn't exist, okay? So if these two would not have been the same, then up here your answer would be does not exist. Okay? All right. I'm going to have you work together. We'll first write it down. But after you have it written down, I'd like you to work together on the limit as x approaches 1. Yeah, it should not be silent in here. And that's okay.
Sorry, either way.
That's two.
Oh, that's one.
Every time the con is done, she waits till the very end to give us like
So we'd be pulling in
That's great, and then we just drop from there.
So two.
if you guys started on some grade
How many of you need more time? Okay. Rebecca, what did you and your classmates do first?
We took the limit of f of x as x approaches 1 over left.
You took the left side, and what did you plug 1 into?
The x cubed plus 1.
Okay. Left hand limit. Plugged 1 into x cubed plus 1. Do you agree?
Yeah.
Okay. Nick, what was your next step?
We did the limit for f of x as x approaches 1 from the right side.
And you plugged 1 into?
X plus 1.
Well, that wasn't very exciting, was it? What's the limit?
2.
2. Okay.
Yeah.
Write down this example. Did you think that I was done?
I always confuse the page.
I do.
I know, I've been like skipping around. How about this? This is our last. Oh, that should probably be an f of x. Thank you for looking at that. That would make more sense for us. So, based on my advice given about a week ago, or no, given on Friday, Monday. Based on my advice, seriously, Monday, I know that was only 4 days ago, but it feels like a week ago. Anyone else? Oh, yeah, okay. On Monday, I advised you about a graph. And I said, remember this graph.
I don't remember.
Must be the one that goes like this.
Go look at your notes. I said, remember this graph. I don't have arrows on mine.
This one. This one.
Okay. Absolute value of x over x. Should look like this, right? Okay? So, think silently in your head. Think silently in your head. Absolute value of x minus 5 over x minus 5. Think silently about how that's going to look. Aaron, how is it going to look?
It's gonna have like one line that's going to the right, and another line that's not connected to the left at 5.
We have a shift to the right side. So I'm asking you to remember this. So I put this up here and you guys were like, oh, it doesn't exist, right? But I do want you to think about the graph. Okay? So the limit as x approaches 5 from the right side would be 1. The limit as x approaches 5 from the left side would be negative 1. So this limit doesn't exist. I guess I can write all that down. Okay. Now, if I asked you for the limit as x approaches 4 of this graph, would you be able to do that? Yeah, for sure. So don't just assume that because I give that to you, automatically I'm giving you a limit that doesn't exist. Same thing with a different piecewise function. Like, let's go back to this one. If I gave you the limit as x approaches 2, would you have to do a left and right hand limit? You would not. you know that 2 fits only in this domain, so you could do direct substitution with x plus 1. You would only need to be worried about that break in the domain. Okay? So make sure you think through your limit before jumping to what you need to do. Does that make sense? Okay. All right. Questions?
Yeah, during lunch. We can announce it.